Good evening, astronomy enthusiasts and education majors. My name is Matthew Perkins Coppola. I'm an assistant professor of science education at Purdue University, Fort Wayne, and I'd like to recreate the activity that I did on argumentation with my students on Friday, February 21st, 2019. Right now, we're looking at the night sky in a simulation software called Stellarium. And you'll notice that in the western sky, there are two planets that are visible. These planets are going to be the subject of this argumentation. We are doing the CER model, which is claims, evidence, and reasoning. Right now, we are in the evidence collection phase. This is the approach I'm going to take to CER. And these two planets being in the western sky are going to serve as our anchor phenomenon for this activity. So we're going to be engaged in scientific practice 2, which involves modeling, and we're going to engage in practice 7 from the Next Generation Science Standards, which is constructing arguments. So we have these two planets, and we want to collect some data on these planets. And a simple way to do this, if we were looking at the actual night sky, we would use our hands to make measurements to see and estimate how high each of these are in the sky, or what we call the altitude. And we might measure their direction based on cardinal points, north, south, east, and west. But another way that we do this in astronomy is we make a measurement called the azimuth. So I'm going to click on Mars, and the software gives me some information about this. And you'll notice over here on the left, it gives me the azimuth measurement first, and then the altitude measurement. So Mars is about 49 degrees high in the sky, which means if I set the horizon to 0 degrees and I set the point in the sky directly above my head, if I look straight up into the sky, if I set that to 90, that means that Mars is a little bit more than halfway to that point directly above us in the sky. It's at 49.8 degrees. And that azimuth measurement of 237 that we're looking at here, that azimuth is with north set to 0 and then moving clockwise around the Earth through those directions from north to east to south to west. West would be a perfect 270. That's 90 times 3. And so we're not quite to a perfect west position for Mars, and that's pretty clear from our picture. Here's Mars, here's the west, and Mars has definitely not made it to that point. So we're going to record this information in a table somewhere, and we're again going to note that this is in the southwest sky. We're also going to make a measurement of Mercury. So I'll click on Mercury, and we can see that Mercury, being closer to the horizon, is only at about 8.2 degrees above the horizon, so an altitude of 8.2, and an azimuthal measurement of 257.8. So we write those down in our table. Now, one other way that we notice the position of planets as we're trying to figure this out is by constellations. And without getting too much into constellations, in our modern times, constellations are actually defined as regions of the sky. And so I can click a button here and draw in what kind of looks like, for lack of a better way of doing this, if I'm drawing the analogy to a map of different properties, these would be like the assessed property lines for each of these constellations. But when the average person thinks about constellations, they're probably thinking about the stick figure pictures that connect the dots between these. And each of these constellations has a name. And so I click this button, and we see now one other way that we can describe these constellations is by their relative position to these to the planets, to these constellations. So Mars is in Aries, and we see that Mercury is actually listed here as in the constellation Aquarius, which for the most part is actually below the horizon at 7 o'clock. This is 7 o'clock, by the way. It says 19 because this is displaying military time, so don't let that throw you. So this is our measurement at 7 o'clock. What will the sky look like at 8 o'clock? Take a moment and make a prediction. Hit pause. Okay, I don't guess I can tell you to unhit pause because, you know, if you didn't hit pause, this wouldn't have gotten to this point of the video. So at any rate, hopefully you have your prediction in. You made that prediction. You restarted the video. Good. So what do you think the sky is going to look like in an hour? Well, let's see. I click this button, and I've shifted the whole sky by 1 hour. And you'll notice that Mercury is gone. You'll notice the sky is darker. And you'll notice that Mars is still in Aries. And if I click on Mars, we have a new position. Mars was a lot higher an hour ago. Now it's down to 39.6 degrees. And it's shifted a little bit westward. It's now at 251. So a little different position now at 8 p.m. And again, Mercury has set somewhere in the west. So I'm going to get these constellations off of here so that we can see the sky a little clearer. And I'm going to jump back an hour, and I want to go through this minute by minute so that we can see the pattern of what's going on. So 60 clicks later, we will be at that hour, and we can now see that Mercury is setting fairly close to the west. And we could even find that Mercury is setting at about 15 till 8 p.m., so 7:45. And if you're looking closely at the altitude and azimuth numbers here, you could actually plot that minute by minute. But we're going kind of hour by hour in our data table because we don't need a minute by minute precision. But we can certainly see this pattern by which the stars and Mars and Mercury all seem to be shifting down and to the right. They all seem to be shifting westward in our sky. We're going to add some more observations to this in the next video, and perhaps we will get to see Mars set in our sky as well.